Okay, these notes are solutions and solubility. Okay, there are three main types of solutions. You have a saturated solution, which is a solution in which all of the solute that the solution can hold at a given temperature has been dissolved. Then you have an unsaturated solution, a solution in which more solute can be dissolved at a given temperature. And then there's the supersaturated solution. A supersaturated solution is a solution that has more dissolved solute than normal for a given temperature. Okay, the ability of a solute to dissolve in a solvent at a given temperature is called solubility. Solubility is dependent on temperature and pressure. Well, for solids, it's mainly dependent on temperature. For gases, it's dependent on temperature and pressure. We can use a solubility curve to gain a lot of information about the solubility of certain salts in a particular solvent. Okay, this is a solubility curve. And what you're going to notice here, this one is in 100 grams of water. So that number's not going to change. So these numbers here are your grams of solute. So it's the grams of solute that can be dissolved in 100 grams of water, which is your solvent. And then, of course, over here is the temperature in degrees Celsius. So that's how we're going to learn how to read one of these solubility curves. But the one thing you have to understand is these little numbers all the way up, that's the grams of solute. Okay, let's do an example. Which salt is the most soluble at 40 degrees? Well, we're going to take our 40 degrees, so there's 40. We're going to go all the way to the top. So it's NaNO3. So the most equals NaNO3. At least according to this curve. Obviously, this doesn't have every single salt available. This just happens to have a sample of them. Okay, let's go with the next one. Which one is the least? Well, at 40 degrees, this one is at the bottom. So this is the cesium sulfate. So Ce2SO4 3. Okay? Okay, our next example. How many grams of KNO3 can be dissolved in 100 grams of water at 50 degrees Celsius? So we got to find our 50 degrees. Okay, and then we're going to go all the way up to find KNO3, which is right there. And then we're going to go over, and it's 80 grams of KNO3 can be dissolved in 100 grams of water. Okay, when reading the curve for a particular solution, any amount of solute above the solute line is supersaturated. Okay, it's a supersaturated solution. That means it's holding more solute than it's supposed to be able to. Remember, these lines, the solute lines, those are how much the maximum. That's the maximum that can be dissolved in 100 grams of water at that particular temperature. So, which brings me to the second one. Any amount of solute on the solute line is a saturated solution. Okay, remember, saturated means you're holding as much as it can possibly hold at that temperature. If you're holding more than that, you've got supersaturated. So any amount of solute below the solute line is an unsaturated solution, because that means it's not holding as much as it can at that temperature. Let's look at some examples. It might help if we looked at them. Okay, tell whether the following solutions are saturated, unsaturated, or supersaturated. So let's take a look at A. 30 grams of KClO3 at 70 degrees Celsius. So the first thing I'm going to do is find the 70 mark, 70 degrees Celsius, and then the 30. And I'm going to go over it. So that's my dot. That's how much. Now I'm going to look at the KClO3 line. That dot is below the line. So A, it's unsaturated. So at 70 degrees Celsius, I can probably fit about 32 grams, maybe 34 grams. I don't know. It's really hard to read. I'd say about 34 grams, between 33 and 34 grams. I've only got 30 grams, which means I can actually fit more in there. So it's an unsaturated solution. Okay, let's look at B. We got 40 grams of NaCl at 95 degrees Celsius. So 95 is right in between here. So we're going to go up to 95 and over to the 40. Oh, yeah, look at that. Now, that's kind of hard to see. It's on the line. And if you look, that's where NaCl is on the line. So for B, it's saturated. Okay, it is on that solute line. Now let's look at C. We have 140 grams of Ki at 10 degrees Celsius. So I'm going to find my 10 degrees, and I'm going to go up to 140 degrees. Ooh. Now, if you look, it's right above the Ki line. That means it's holding more solute than it's supposed to. At 10 degrees Celsius, you should only be able to hold about 137, 138 grams. But I'm saying, no, there's 140 in there. So this is a super saturated solution. Okay, hopefully that helps. Okay, most solubility curves are done in 100 grams of water. Sometimes you need to know how much of a particular salt can dissolve in a different amount of water at a particular temperature. You can use proportions to calculate this amount. So let's do some examples so you can see what I mean. Okay, so for this example, we want to know how many grams of NH4Cl can be dissolved in 250 grams of water at 70 degrees Celsius. Well, the proportions that we're going to be using for all of these is the amount of solute. Remember, that's the salt per amount of solvent. And that's, in these curves, that's the water. So I'll put water underneath. Okay, so first we have to find out how much can be dissolved in 100 grams. So I'm going to put my two little lines here. So I'm looking for 250 grams, but my curve has 100 grams. So now I'm going to find NH4Cl at 70 degrees. So there's my 70 degree. I'm going to use red here. So NH4Cl is right there. So that is 60 grams. So I'm going to put my 60 grams up there. Now, just like we did with the gas laws, we're going to be cross multiplying and dividing. So X equals, remember, 60 times 250 divided by 100. And when you do that calculation, you get 150 grams of NH4Cl as your answer. Okay, so let's try it again. Let's try another one so we can practice a little bit more. Okay, for this example, how many grams of KNO3 can be dissolved in 415 grams of water at 45 degrees Celsius? So I'm going to set up my proportion. I'm looking for 415 grams of water, and I have 100 grams on my curve. So if I go to, let's see, we're looking at 45 degrees Celsius. That's right there. And then we're going to go up to the KNO3 line. So that's right there. So that is, if you go over, that's 70 grams. Okay, so now X equals, it's going to be 70 times 415 divided by 100, which is equal to, it's 290.5 or 291 grams of KNO3. Okay, let's try one more. Okay, this one's a little different. It's asking for the amount of water. So it's saying how many grams of solvent or water can 55 grams of NaCl be dissolved in at 95 degrees Celsius? I'm still going to set up my proportion exactly the same. I know I have 100 grams of water, but this time I'm going to put an X for the water because we don't know what that is. That's what we're trying to calculate, how many grams of water. So I'm saying I have 55 grams of NaCl. I want to know how much water I need to make a saturated solution. So at this point in time, we're going to find the 95 degrees Celsius, which is right here, and we're going to go up to NaCl, okay, and that's 40. So we're going to put the 40 grams up here. So now X this time is equal to 100 times 55 divided by 40. When we do that calculation, we get 138 grams of water as our answer. So if I have 55 grams of NaCl at 95 degrees Celsius, I can put 100, I need that. Sorry. If I have 55 grams of NaCl at 95 degrees Celsius with the water, I need to use 138 grams of water. Okay, hopefully you guys understand this. There'll be some practice problems at some point or a worksheet to work on these problems with, and there'll probably be a quiz in a couple of days on this. So make sure you understand how to do this. Have a good day. Bye.